right, welcome to John Park's workshop. It's me, John Park, and we're here. We're right here in my workshop. Can you believe that? I can. It seems real enough to me. So let's get this thing started, huh? This is our first sort of normal show back into the new year. Last year was a retrospective, and I did a holiday one that was, I don't know, all sorts of goofing around. But we are gonna do a normal show, as normal as I can muster, at least. So let's see, to start it off, first of all, I'd like to say hi to the people who are watching over in YouTube, as well as on our chat in Discord. If you're watching over on Facebook, hello to you, but I'm not watching that chat. Same with Twitch, I'm sorry. Just the two eyeballs, so I'm gonna keep an eye on the YouTube chat and Discord, and please check those out if you're looking for a place to chat. Discord is a terrific one. I highly recommend it. Let's see, we'll kick it off with our Help Wanted sign. I don't know if you knew, but I broke my Firefox capture. While I fix that, we'll mention that we have a jobs board. Adafruit jobs board is free. It's free now. It's going to always be free to post your positions or post your resume if you're looking for work. Let me find it. Where did it go? Where is your? Oh, there it is. There's our jobs board. Are you ready? Bit of technical glitch there as we get going. So these are some of the positions that, or rather, not positions, but resumes people have put up. We've got some interesting skills on offer. People with web development skills, fabrication, art and design, a neuroscientist by training, but a hardware and software engineering enthusiast with a passion for public art installations, available in New York, New York. So check these out if you're looking to hire someone on a contract basis for some freelance work, for some full-time work, remote, local, in-person, robot to robot. All sorts of options are available over on the jobs board. So head to jobs.adafruit.com and check them out, won't you? Let's see, what else have we got? I should mention that if you want to get the next Ada box, you can go ahead and sign up now. So this is going to be shipping in March of this year, 2020. Not shipping last year, not shipping next year, but this very current year, you can get the next Ada box 15, is going to be shipping in March. So don't be fooled by the little holiday Santa me there. That's a video from the last unboxing. But we'll be doing a new Ada box with exciting contents and exciting curriculum, things to learn, projects to do. And those go quick. So we have a lot of people who carry over their subscription from quarter to quarter. So there won't be a ton of new openings for subscriptions. But if you're interested in subscribing or signing someone else up, go ahead. That's what I recommend. Now, speaking of the store, this is a coupon code that will get you 10% off in the Adafruit store today until 11:59 p.m. Eastern Time. You can use the coupon code MagicLight, Magic-Light, to get 10% off. It's not good on subscriptions or gift certificates or software. Code Academy, is that the one we have? I think it is. But it's good on goods, real stuff. And so since I've mentioned goods and real stuff, I want to mention my product pick of the week. And I've actually picked this one before, but I have a new motivation for picking it this week because this is our IR, that's infrared thermal camera featherwing. It's the AMG 8833 IR thermal camera featherwing. I happen to have one here mounted on the back of a Pi Gamer. And this is sort of a little tease for an upcoming guide from our very own friend of Adafruit, C. Grover. And I'm going to turn it on here, and you can see this is the thermal camera that, put my hand up there, you can see it sort of tracking things, is a really impressive use of our thermal camera and the Pi Gamer. You can also use it with Pi Badge. In Circuit Python this is running, and it's got a really impressive set of features using the buttons and joystick UI that's available here for doing things like setting a baseline for an alarm and then being able to monitor if something goes over that temperature. So very accurate, and it's a 64 by 64 pixel display. In fact, let me show it on my little overhead here because that'll look nicer. It's a little blown out on my other camera, so I don't have anything super hot here to put in front of it. I'll light a match or something. How about that? I've got a match. Do I have something to strike it on? It's a strike anywhere, but those don't always... Yeah, we got it. All right, here we go. Whoa! Yeah, it's very impressed by that that match there. Here, let me switch cameras again. So you can see here. It's worried that I'm setting my workshop on fire. So that's an upcoming guide that C. Grover is working on, and it utilizes our PyGamer or PyBadge, or the Edge badge also, and the infrared thermal camera Featherwing. Just goes right on the back there. Couldn't be easier to set up. I haven't looked at all the intricacies of what you can do with the interface yet. I plan to, but it's really fun for just kind of scoping around and looking and see if you got hot air leaks coming out of ducts and things like that, or for detecting matches that you probably shouldn't be lighting. So that is my product pick of the week. That's the IR thermal camera Featherwing. Now let's see. You know what this brings us to? Let me get a little setup. I'm going to try to find one of my hiding browser windows here before I move on. There we go. Is that it? It is. So it's time for the Make Code Minute. Let's go to small me, not medium me. Come here. There we go. All right. I'm going to try to shift this just a little bit. And let's pop that over. There. Okay. And yeah, we can do this in the simulator here. So for the Make Code Minute today, what I'd like to look at is setting up a sort of countdown timer using the Circuit Playground Express inside of Make Code. And what I've done here is I've set it up so that we have a number of neopixels here that each represent 1 second. And in the interface, you can press the A button to increase, or rather the B button to increase, the A button to decrease. And then when I press the A, B buttons together, it's going to start counting down. Now, you can't press those two things at once with a mouse, and that's why the simulator pops up this little AB. In fact, let me go to a full screen simulator so you can see. Here's my B button increasing the countdown. And now I'm going to press this little combined magical AB button here. And so you can see it's going to count down each second, and then it gives us a little flash of orange and some sparkles. There's also some sounds. You're not hearing them on here, but in fact, if I do it on my real Circuit Playground that I have hooked up here, we should be able to play along. So you can see each time I increase, we're getting lights there. I'm going to press them both together. And the thing I wanted to show you inside of Make Code itself about that is this AB button press. So there's other stuff you'll want to look at in the code, such as setting up counters and correlating the number of times you've pressed the button to a variable that will then correlate to the number of the pixel that's displayed, as well as counting it down. But this is the key thing here for using AB button. We actually have nothing fancy necessary. There's actually an AB button that lives right here in the on button press, which is part of the inputs. So when we press that, I'm setting the pixel color at the current number, the counter variable, counter current pixel to green. And then every second we go through and reduce that number by 1. We play a tone, and then we set the preceding pixel to black so that it disappears as we go. And so that's how you can use the AB buttons on the Circuit Playground Express to set up a little countdown timer that you can adjust. And that's your Make Code Minute. All right. Just checking in with the chat here. Yeah, there's no worry. I have not set anything on fire, and I do have a fire extinguisher back there. You can usually see it on my camera. It's a little obscure today, but I do have, I'm about 3 long steps away from a fire extinguisher, in case you were worried. All right, so let's also take a look at speaking of Make Code and Make Code Arcade, this is my Make Code Arcade Game of the Week. And this is actually more of an in-progress demo. And it is just the forum post. Let me zoom this up for you. The forum post was Moving Platform by 3ISSA. Threesa? I'm going to call you Threesa. And Threesa is making a platformer game. Has done some beautiful graphics, which I'm really impressed with. Custom sprites, custom color palette. But the question that Threesa has is about moving platforms. So in a lot of games, there are platforms that move that characters can jump on. How do you create those? And a very specific thing I'm going to show here that I thought was really clever. Now, Threesa has some questions about improving this and refining it, but has already made some really impressive progress with it. And I wanted to show you this little facet of it. So if you take a look at my simulator here in Make Code Arcade, there's this cute little knight character, and I can jump and get this great little secondary animation on the feather on the knight's helmet. I'm getting a very sort of Shovel Knight kind of vibe on this. I love it. And what I thought was really cool is this. I can jump from underneath a platform and then land on the platform. Now, this is trickier than you might think at first. We're used to that sort of behavior in games, but how does that work? Well, we need to be able to go through a thing, but then not go back down through the thing. And so I thought this was a really great solution to that problem. If we look here inside of Make Code Arcade, there's a function for placing platforms, and there we'll just take this this one example of one platform. I'm going to zoom up in here, in fact. The way the logic of this works, oh, I'm a little too zoomed in for you to see that. How's that? Yeah. So the way the logic for this works is there is this if-else block that whenever a tile is below the hero of this type, so in this case it's actually, I believe, this one. So the tile that looks like that, we run through, and if the tile is below the hero, we turn the wall parameter on. If not, if it's to the right, left, or more importantly, above the character, then the wall parameter is set to off. So that allows us to pass through it and then stop and not come back through it. And this is actually one of the nice features of the new release version of Arcade, is that now we can see the little graphics as pickable tiles. So the attributes that we associate with a tile aren't based on an index color anymore, it's based on the actual tile. And so that is how it's possible to create both moving platforms, as we see here, that we can jump underneath, as well as, oh, I'm getting stuck. That was part of the question. How to not get stuck on those. As well as how to jump up from below a platform, go through it, and then land, maybe, on top of it. Oh, I'm not very good at this. And I'm determined I'm going to get through this. Oh, maybe I can't jump. There we go. So really cute game, beautiful really, and an excellent solution for this problem of going through a tile and landing back on it. So check that out. I'll put out a little separate video for this later, and that is my Make Code Arcade game pick of the week, and it is from the Microsoft Make Code forums, and it is Moving Platform. All right. Let's check in on Discord, and I'll have a look over on... Oh, so hey, question I got from Maxim Kulkin on YouTube. What happened to the frames per second? So I'm hoping that's not the frames per second of me part of the video. Hopefully that's streaming just fine. But the game itself, it does not play well through the video broadcasting software. So it's running probably 60 frames a second or something like that when I'm seeing it. It's very nice and clear, but the broadcast software and sending it out, it ends up looking kind of slow. So hopefully it's not me looking slow and weird, and it was just the game. Thanks, Connor McCarter. But yes, that is unfortunate that when maybe we can tinker around with that this year and try to find a better way to capture and broadcast those, because the way I'm doing it right now makes it slower. All right, so other questions? No, it looks good. Oh, hey, Todd Bot. What are you saying is a combination of fire extinguisher and cigarette lighter with Bluetooth? Maybe that should be next week's project, in fact. All right, so let's see, what else have we got? I'd love to talk about I'd like to do a little demo actually here and a little explainer on Bluetooth Low Energy, or BLE. And it's related to my project of the week, which is this BLE light bulb. In fact, I'll just give you a quick glimpse of that bulb, just so we have some context, right? So that's a light bulb. Wait, let me get rid of the medium me. Here we go. That's a light bulb, and it's red, but it doesn't have to be red. I can change it. As you see, I just sort of dimmed it there. Let me bring this up in front of camera. So this is a little color mixer that allows me to pick red, green, and blue, and it has some other features that I'll show off when we get to it. But before we dive into kind of how that's built, I'd love to talk about Bluetooth Low Energy in general, because it can be a bit of an opaque topic, and I've been working on figuring out how it works, and B, how to explain it. So I'm going to take a crack at some of that, and I think a nice way to do it is with a demo that I have running on my iPhone, and this is a piece of software from Nordic that's called NRF Connect, and it's a general purpose BLE app. It works with a lot of different devices, so it's not specific to just Nordic chips. But what I'm going to do is let's wake my phone up here, and what we can do is I'm going to go ahead and hit scan on here. And what it's going to do is going to look for Bluetooth Low Energy devices. Now, Bluetooth Low Energy is essentially a subset of the Bluetooth spec from Bluetooth 4 going forward. And it's designed for a very limited set of, or sort of a subset of scenarios where you're trying to do communication among devices, where your main goal, like it says in the name, low energy, is to keep the energy consumption down. So this isn't for Bluetooth speakers that are streaming lots of data all the time. This is not for headsets. This is for small things that send out just a little bit of data, can receive a little bit of data, and they can operate in a couple of different modes. So yeah, this is an app that's available for iOS as well as Android. I'll show the Android app more later. I've got a Android tablet coming in. It is far superior to the iOS version. It has a lot more features, looks a lot nicer. But this is what I have right now to show today. So the first concept here is that there are two modes in which Bluetooth LE devices operate. And the first is essentially a broadcasting and observing mode that is defined by this acronym GAP, which is a generic access profile. And I'm going to look at my notes here because I made some to try to make explaining this as clear as I can. In this mode, what we have is devices that are considered peripherals, and they are just sending out little bursts of advertising broadcasting. And so nothing's connected to them, but they're turned on and they're saying, here I am, here's my information. And so that can be any BLE peripheral device, and it can be ones that never intend to connect to anyone else, such as beacons. Beacons just send out a little small amount of information all the time, and then other devices can read that. So those can be used for things like location, proximity data. Peripheral devices are sending out this data, and right now, with nothing connected to this bulb, I've disconnected my little slider from it. I'll turn it on. That's a peripheral that's sending out a little bit of information that just says, hi, I'm a bulb and I'm sitting here. That's kind of the extent of it. Then on the other side of this equation is a thing called a central, and that's often your phone. So right now the phone is able to observe this broadcast data. And so when I go and hit scan here, we are getting those little advertising packets that are being broadcast by the peripherals. This central device is picking those up, and it's displaying some of the info for me here. So if I scroll through this, I'll see a bunch of different Bluetooth devices, and here's one, the LED blue 19592CBC. That is that bulb. And we can see here the advertising isn't just saying, hi, I exist, but it actually contains a little bit of other information, including some services that are available. And we'll get more to that in a second, as well as it's showing me its transmit power. So not only do these broadcasting peripherals say, hey, here I am, but they also are laying the groundwork for establishing a connection if you want to do that. So right now, every central, 10 phones could be in this room, and they would all know that that bulb exists. But the sort of next step of it for a scenario like this is called GAT, which is the generic attribute profile, or generic attribute profile. So in this scenario, what happens is we establish a exclusive set of connections between what was the peripheral and the central, and those become a server and client. So essentially, I want to pair with or connect to that bulb. Actually, pairing is the wrong word here. So there's really it's a connection that I'm going to make. While it's in advertising mode, the bulb is saying, here's how we can advertise. So it's laying some groundwork, essentially agreeing on some terms about how often data is going to come, and the format of that data, and even the frequency hopping within the Bluetooth LE spectrum that's going to be done so that they can stay in sync with each other. So that's information that I can see some of it here. Now I'm going to go ahead and hit connect. So what happens now is the app is showing me a little graph of advertising, which I haven't looked closely at, but I assume it's giving me just a signal strength over time. But more importantly is if I swipe to the side here, we have now made the connection. So we are now in this server, the bulb is serving up information, and client, the phone is acting as the client. And there are these three services. Now, these services don't have nice names on them in this case. I'll talk more when we go into things like heart rate monitors about some sort of predefined profiles and services like heart rate monitors and bicycle cadence computers, glucose monitors. There are a handful of profiles that have been established by the Bluetooth Special Interest Group. This is not one of them. This is sort of a generic use, so not everything has a nice name. But I'm seeing there are three services on here, and as I scroll down, I start to see what's called here is an attribute table. And this attribute table is a hierarchy of characteristics and data. So the characteristics can be things like heart rate and battery strength and the position of a sensor on your body. Again, this app doesn't give me very many nice names. You can go through, however, and read some of that data. So let's see if we get anything to show up. I'm pressing the little down arrows, and for some of these characteristics, let's see, is it going to show up nice? It's not. I'll show you in another app that'll show the names, but the characteristics that this bulb is exposing that you can read and write to are essentially the red, green, blue, and white individual attributes for telling the bulb what color to be, as well as there's a characteristic for a sort of concatenated RGB, so you can send this as a single packet that says what color to go to, although it excludes the sort of warm white mode. So I will show you that another time in the Android app where it gives it nice names, but I do happen to know just from that and fooling around with it that if I say I want to go and write data to this first characteristic happens to be the red characteristic on the bulb. So what I'll do is I'll just send that full strength. So it's in hex, so I'm sending a value of 256 or 255, I guess, because it would be 0 to 255, and that's this FF. And when I write to it, it just went to full strength on the red bulb. Now, it's showing up kind of purpley, and that's because I still have some blue on there. So what I can do is, let's see, these are FE6 was red, 7 was green, 8 is blue. So I'm going to send a 0 into this blue characteristic. So this attribute of 0 gets written, and now the blue just dropped out of the bulb. So that's probably as far as I should go showing this general example. It'll be easier to look at some of these hierarchies and how they work when we do a more standard thing like the heart rate monitor. But what I want to show you now is, since we have these profiles that in some cases are well defined, in some cases are just reverse engineered, what we're doing at Adafruit is the CircuitPython team is writing libraries that allow us to get and send or read and write information to these devices through libraries. So we have a library for the MagicLight bulb. So let me show you actually inside of Moo here, and I got to open it so I can read it. Where'd you go, Moo? So this is our code example, and I'm writing a guide for this. It'll be out on Friday, or I'm publishing it on Friday, or submitting it for review on Friday, actually. Cross fingers, it's a quick review. But this code is mostly making it very nice and digestible to do some things that we have the nitty-gritty details of inside of a couple of primary libraries. So there's the Adafruit BLE library, and then there's also a MagicLight library. I think it's CPB BLE MagicLight. And so what's going on in this script here is, first of all, we are importing some libraries, including the Adafruit BLE, BLE IO, board, analog in. That's because I'm using some sliders. And I'm importing the Adafruit Circuit Playground library, which makes it very convenient for me to talk to other things on the board, like lighting up the NeoPixels right on the board, use the slide switch, the buttons, and so on. And then here you can see I'm importing the advertising standard provide service advertisement from the BLE library. And what this is part of is allowing me to filter down when I have a Circuit Playground Bluefruit instead of my phone. The Circuit Playground Bluefruit is going to see all these Bluetooth devices floating around out there. And this is just a way to very quickly filter down to what we expect. So we're filtering down to things that have a provide services advertisement, which means they can be connected to. And we get even more specific and import this MagicLight service, because that's the one we're going to be using, which we created to do this one thing. This is our little procedure for creating that connection. It will basically try to make a connection until it finds one with MagicLight service. And here we define the BLE radio. Now I've got a little helper script that is, and I'm going to zoom this up actually even more so you can see it better. Sorry about that. So I've got a helper script here that I'm using to read analog inputs, because I've got alligator clips connecting 3 sliders. This could be potentiometers, or you could do it other ways. Setting my pixel brightness on the board itself, on the CPB. And then I'm setting a variable called dimmer that I'm going to use for something in a second. Then we have our, we actually now instantiate the find the connection. And what we return from that are the active connection and the bulb, which is essentially the RGB color packet we're going to send to the bulb later. Then once we start the main loop of the program, we check if we don't have an active connection, then we make one. And the first thing I'm doing is I'm setting a NeoPixel to yellow on my board. I'll show you that in a moment. And that just lets me know that my Circuit Playground Bluefruit is not connected and it's trying to connect to a bulb. And then this is where we start, like I said, scanning through the radio advertisements that are being broadcast to see if any of them are provide services, and then if they are MagicLight. When we do get that active connection, then we print out just to, for convenience, to the REPL here that we've got a connection. I set the pixel on the board to blue, so it kind of feels like, hey, we got a connection. I actually play a little tone, boop, and lets me know that we're connected. And then we are going to make sure that we have that connection. If something has gone wrong, then we can break out of that and continue to try. But once we are connected, we have this while active connection is connected. I start checking my switch, my buttons, and my sliders. And here's the key thing. You saw when I was using the phone app, I could send like a red or a green or a blue. And there's actually a way from there to also send RGB. Here's how I'm doing it from the Circuit Playground Bluefruit instead of the phone, which is I check all my sliders, and depending on where they're set, I get this color value. Color equals R, G, and B. And then I try sending that to the bulb. So that's the key line right there. There's only one bulb here. It's bulb 0. And I send it the color. So we're acting like almost like it's a neopixel. If somehow this were a two-headed bulb, we might have bulb 0 and 1. And that gets sent anytime I run through this loop. I'm sending that color information. And that's it. That's all that's happening in the code. So let's see it in action. I'm going to actually go over to the workbench here. Let me hide that. And I'll put up let's do that overhead. And I'll head over here. So there you can see I have a second one that I made. It's a little nicer. So I've got one on a breadboard. I also have a little PCB that I made that allows me to solder on some sliders. So there's my Circuit Playground Bluefruit. I'm going to plug a battery into it. And I might still be connected on my phone, so I'm going to actually turn off the bulb and turn it back on so that I drop that connection in case it's still active. Okay, so you can see it just got connected. Let me hold this up closer here. I can zoom in. So I'll reset this board. You'll see it go yellow and then blue. So that means it's connected to my bulb. And then let me move this to the side a little bit. Okay. And sorry, this is very blown out on video. I'm doing my best to try to reflect some color there. But here you can see that on my Circuit Playground Bluefruit, I have the connection pixel is this blue one. And then I have percentages, essentially, of red, green, and blue. So if I change my sliders and crank it up to blue, you can see, let me do green, that's a better example. You can see we have kind of full-blown green. And then this pixel over here tells me what color am I sending to the bulb, because it might be a mix of those. So if we put in a little bit of green and a lot of red, that's going to be orange. And so we have an orange pixel here, and we have an orange bulb. Oops, there goes my reflector, oh well. So that's a lot of fun to just mix colors on here. And I decided to add a couple of other features to it just because we had have the buttons and sliders on the board. So I can go to a dimmer mode. So if I flip the little switch on the Circuit Playground Express, I get a dimming effect, so it just halves any values that I set. I'm not being clever with gamma or anything like that, so it's probably not perceptually half, but it is half values, and that just allows you to move the sliders a little more freely without just blowing out colors to white. In fact, it won't go full white until I flip to this. And then I've also got a couple of different blinky modes, and this is manual blinking, so I can hold the A button and it just sends 0, 0, 0 to the colors. And that, you can see how fast, right? Bluetooth LE, you might think it's not fast, but if you're just talking about sending data like a little button press, or, essentially these colors changing, it's fast. I mean, that's keeping up with me. And then this one does the opposite. It sends full brightness, so FF, FF, FF to all channels. And you can see it looks kind of bluish when you do that, but that's the full white of the bulb. And that is all working on that one characteristic of the Bluetooth bulb, which is this, this unique identifier. It has a universal unique identifier, or UUID, that is exposed in our library. If you want to look a little closer, you'll see the name of that. And that gives us, oops, am I not? Oh, I didn't plug this in, sorry. I thought I was going to be slick and change cameras without even saying anything about it, but there we go. So the there's just this one UUID that's the characteristic for RGB value of the bulb. And that's all I'm writing to every time with anything I'm doing here. It's just sending those UUID values to that one characteristic. And I'm not using those separate ones that we saw. Now, we're a little over time, so I'll try to keep it brief here. But one thing I think is really cool is, and I haven't exposed that in this program, but if we go back to the phone here and connect, this light bulb actually has a, let's bring up the phone again there. I'll put a small me there. So the bulb is on right now, but it is at 000 for red, green, and blue. However, if I reconnect on the NRF Connect app here, and let's see, I need to drop the connection of my Circuit Playground Bluefruit, or it won't allow me. You can only be connected to one thing at a time if you are the server. So now that I'm connected, if I scroll down here, there's actually a characteristic for the white bulb ring. So this is an RGBW bulb, so you don't get white by combining red, green, and blue, because that always looks kind of gross. You can actually get white by turning on these warm white LEDs. So that's really nice. That looks like an incandescent bulb type of color temperature. So that's pretty nice. So let's see. Oh, there's some questions in the, let me pop over into the chat, because I know this stuff is confusing and I'm half confused about it half the time. So let's see how we do. Question from Todd, and he says, wait, so I think I missed something. The Circuit Playground is acting as a BLE central to control a standard BLE bulb. So the terminology here is actually, when they are connected, it's a server and a client. And so the Circuit Playground Bluefruit is a central when we have not yet connected. And then the moment the connection is made, those two names go away, because we're no longer in GAP, G-A-P. We're in the attribute side, which is the connected side, and that is the GATT, generic attribute profile. When we get the connection made, the bulb is the server, because it's, well, that's just how people decided to call it, but it is the server, and you can think of it as like a website that you can send info to or get info from, and the client is your Circuit Playground Bluefruit, and that's like the thing you're holding. That's your computer. That's your local thing. So hopefully that helps it to make sense. So yeah, that's been kind of the big innovation here, is that CircuitPython running on any of our NRF 52840 boards can actually be a client. And interestingly, that relationship, the client can be connected to multiple servers. So just like your phone can have Bluetooth earbuds in and a Bluetooth keyboard talking to it, you can have multiple servers talking to that central, and that's maybe how that name central got used there. So hopefully that's not too confusing, but I'm going to have some clarifying language in the guide for that, and we have some excellent guides up already. Also, there's if you want to get a little more in depth, one of our good friends of Adafruit, former remote employee in Spain, Kevin Townsend, or K-Town, as a lot of you know him, wrote, along with some other people, this book, Getting Started with Bluetooth Low Energy, and I recommend that, as well as any resources you can find online that'll help explain things. So let me know if you have other questions in the chat. Yeah, Todd says, having CircuitPython not just be a BLE peripheral is wonderful. Yeah, it's really cool. And if you go back to some of the projects that I did for, and other people did for the AdaBox 14, you may recognize this one, which was multiple peripherals that are advertising and their color, and then I was grabbing proximity by just moving another one around. So that is essentially an example of peripheral and central and beacon kind of stuff. But then this project is actually full bore client server stuff without having to use a phone. So very cool stuff that's possible now. All right. Well, thank you so much for sticking in for an extra few minutes. But I think that this can be a confusing topic, and I think it's helpful if you're thinking of doing stuff with Bluetooth to get a little bit of an understanding of how the terminology applies, and then you can dive into some specific examples. Andy Calloway says in the chat, so I guess you could make cool white by turning on the warm white and adding some blue. You absolutely can. I won't do it now because I promised it's time to go. But yeah, if you look online, people have cracked open some of these bulbs, and they're initially surprised to find RGB in the middle and then a ring of warm white, which is pretty cool. All right, well, thank you all so much, and come on back next week for more Bluetooth. Hopefully, over the next few weeks, I'll do some more of these projects as the CircuitPython team is writing more and more libraries to make it really convenient and easy to communicate between things like we've mentioned, heart rate, glucose, even HID, keyboard, Bluetooth keyboard kind of stuff coming over Bluetooth LE. So really exciting times for digging into this stuff. So. All right, thank you so much, and I will have one little last reminder here that if you want to go and pick up some cool BLE stuff, we got lots of BLE stuff. Go get some BLE stuff in the store, or anything else you want that's an actual hard good, and you'll get 10% off if you use this coupon code MagicLight. And by the way, MagicLight is the name of this particular bulb. You can find them at hardware stores and online at various retailers. And that's the one our particular library works with. You might need to do some sniffing and reverse engineering if you use different brands. But all right, well, thank you so much, and I will see you all next time. Bye-bye.